Hello and welcome to University Television Productions Presents. I am Farzan Faramarzi and today I have two guests. One of them was born and raised in Fresno, California. She participated in the Teachers in a Space program, trained as a mission specialist and flew on STS-118 in August 2007. Currently, she is a distinguished educator in residence at Boise State. My other guest grew up and was homeschooled in Boise, Idaho. She is a sophomore at Boise State studying mechanical engineering. She works with Boise State microgravity team and introduced President Obama when he spoke at Boise State in January 2015. My guests have one thing in common. They both share the same passion for science, engineering, and space. Welcome to UTP Presents, Barbara Morgan and Camille Eddy.
Hi, thank you.
Thank you, Farzan.
Yeah, so I should mention that before we go to the questions, I worked on this show and invited you, of course. Camille was here. Welcome back, Camille.
Thank you.
And so it was like 1 year emailing you and talking to you back and forth. I know you are really busy. I'm glad we can make it. I have to say thanks to your office, Wayne. He really helped me out with all the scheduling and make this happen.
Well, thank you so much, and I'm delighted to be here, and it's really fun to get to be here with Camille. We do share a lot in common.
Oh, I knew one of them, so if you do have more in common, please talk about it. So I mentioned you two share one thing, which is science and the passion for science and engineering, and I read one of Camille's interview, which is Camille said, I wanted to go into space since I was 12. And this idea of being an astronaut and going to space or being a pilot is so appealing to kids. I mean, to tell you the truth, I wanted to be a pilot when I was 12, but I'm a journalist right now. So, have you had the same desire when you were 12, Barbara?
You know, that's a great question. So I am quite a bit older than you and than Camille, like a lot older. And when I was a kid growing up, girls were nurses or teachers or moms. And I had graduated from high school. Right after I graduated from high school, Neil Armstrong stepped on the moon. And those were my images. I loved it. I was really enchanted by it. I loved science. I loved math. I didn't know anything about engineering, but that fascinated me. But I didn't see girls doing that. I didn't see young women doing that. I didn't see old women doing that. So it wasn't even part of my thinking that would ever be something that I would do. So I kind of came about it in a very different way. I'm so thrilled that nowadays it is, young girls, young women, boys, anybody can do whatever it is they set their minds to, that they really can make their dreams come true. So it's very different now, and I'm grateful for that.
Great. Camille, as I mentioned earlier, it's the idea of going to space, being a pilot or astronaut. It's so appealing, right, to everybody, almost everybody, I can say. What have you done to pursue the career in space and science?
Sure. Yeah. Well, when I was 12, I did some research and said, how do you become an astronaut? And I discovered to be an astronaut, you have to be a scientist, a doctor, or an engineer. And I was really into putting things together, looking at how things worked. So I knew that engineering was what I wanted to do. And then when I got to high school, came down and visited Boise State a few times, I really explored the field of engineering a lot more with the different summer camps and activities that they had here at Boise State to offer for high school students. I even traveled down to NASA Ames Research Center and just kind of really looked at the field of engineering, how it works down there. So it was many steps, taking it from just an interest to research to saying, okay, I want to be an engineer. And that's what I'm doing right now. I'm working towards an engineering degree, and hopefully that will get me on my way.
So you want to be an engineer, not an astronaut. What's the difference between those things?
So an engineer is my path to becoming an astronaut.
Okay,
yeah.
Okay.
Yeah.
I think that's the best way to explain that.
Yeah, definitely.
So, Barbara, I mentioned some of your positions, like mission specialist, and that you flew on STS-118 in 2007. Would you please explain for us what is the mission specialist is? What is the job is? And what is special about STS-118? What was that, if you explain for us?
You bet, I'd be delighted to. So NASA has, astronauts are astronauts, and NASA has two types of astronauts. There are pilot astronauts who are pilots, so they learned how to fly jets, and all of them are military astronauts, so they did their flying in the Navy or the Air Force or the Marines. And they, especially during the space shuttle days, they were the pilots of the space shuttle. Okay, and then we've got the mission specialist astronauts, and they're all the other astronauts who don't come with the. Many of them actually have piloting backgrounds, but they're not test pilots. And the mission specialists do all the other jobs on whether you're on the space shuttle or the International Space Station. So doing the robotics, doing the spacewalking, doing the science experiments on board. And it's not that the pilots don't do that, but the pilots are particularly focused on actually piloting the spacecraft.
So I have to ask these questions. Have you seen Gravity, the movie?
I have seen Gravity, the movie.
Okay, so in the movies in Hollywood, we usually see one or two astronauts, and they do everything.
Yeah.
They are pilot, they are astronaut, they are engineer. So is that true? So can we have like one astronaut who is a jet pilot and an engineer as well?
You know, that is a great question. So in that movie,
Gravity.
Yeah, in the movie Gravity, who's the main actor? I forgot his name. Sorry about
George
that.
Clooney?
George Clooney. So in that, George Clooney was the commander of that mission. He could have been a pilot astronaut or a mission specialist, because on our International Space Station, either one can be commanders. So it was kind of hard to tell in that situation whether he was a pilot astronaut or a mission specialist astronaut, and it really doesn't matter. Everybody works together on a team. There were some things he did that definitely our astronauts would not be doing.
Okay.
and the actress, Sandra Bullock. I'm sorry, I'm a little tired today, so I'm not good with names. Sandra Bullock was what you would have called a mission specialist astronaut, and you can kind of tell that just from some of the jobs that she was doing, and particularly focused on the science experiments. But it's not who's what, it's that you're all part of a team and a well-functioning team.
Okay, so speaking of astronaut, I have to ask that what is like to be an astronaut, and is there something interesting about this job that nobody never asked about it and you really wanted to talk about it?
Oh boy. That's a great question. So I've been asked a lot of different kinds of questions. So if you have one you want to ask specifically,
I want to leave it to you because I don't want to ask like cliche questions.
Yeah.
So is there something that you always wanted to talk about and nobody never asked?
You know, people have asked this, but one of the things I love sharing the most about space exploration and being an astronaut, first of all, it's a great job. It is a great job. You're working on a mission that is much bigger. It is all of us put together, and it's so much fun to work on something that big that you get to play a very small part of. And it's all about teamwork. It's about problem solving. It's about creative thinking. It's about science, technology, engineering, and mathematics. It's all the things that our students here at Boise State in these STEM fields are learning.
How many people usually, or scientists usually work on a team?
So our team on the space shuttle, our teams were usually 7 people. On the International Space Station, while we were building it, and that was, you asked about STS-118, our mission was to help, we were a construction crew. Our mission was to help construct the International Space Station. So at that time when we were constructing the International Space Station, we would have crews on board the International Space Station of either 2 or 3. So when my crewmates and I on the space shuttle went to the International Space Station to help build it, we already had 3 of our crewmates living on board the International Space Station. 2 were Russian and 1 American. Another great thing about the program is its international aspect. So, and then on our crew, the folks that we brought up with us, we had a Canadian with us as well. So it was a mixed crew. And, but now that the space station is completely built and we've retired the space shuttle, now we rely on our Russian colleagues to get our crews back and forth to the International Space Station. Meanwhile, NASA's working on an advanced space vehicle to take us farther out, either back to the moon or onto Mars, and an asteroid mission, which ties in with what we're doing at Boise State. And I know I can't wait for Camille to talk about that. But while NASA's working on that, meanwhile, in our country, we've got private companies that are working on the replacement for the space shuttle. And that's all working really, really well. But now that the space station's built, we've got usually 6 crew members. Okay. My commander of STS-118 just last week left to go to the International Space Station, where he and one of our Russian colleagues is going to spend an entire year on orbit. So we've got a lot to learn. He also has a twin brother, identical twins. So while Scott's in space and Mark's on Earth, we've got a lot of scientists around the world who are going to be doing some studies on them, because you can do genetic studies and see what happens in microgravity if you've got 2 people with the same genetic makeup.
Oh, okay. Sounds really interesting. Camille was on our show last year, and we talked about the Space Broncos. Sure. What happened to that program? Is it still exist? Are you still involved?
Yeah, definitely. The Space Broncos is definitely still up and running. The reason it hasn't been as active this year is because many of the key leaders, including myself, haven't really wrapped up in other projects, including the microgravity project. But it's definitely still going. We're brainstorming for future plans next year. That will be taking place over the summer and early next school year. And so we're always interested in bringing on new team members, and we'll hopefully have something big planned for next year.
So what is the purpose of the Space Bronco program? Is that like people who wanted to involve in microgravity, they should involve in a Space Bronco first and then get to the next program?
Well, so to get involved in microgravity, there are many different avenues you can take. But I like to say Space Broncos was a way for us to engage the whole campus in NASA activities. It's a way to do something really big with NASA, like a big outreach event, get people aware of the opportunities they have to work in NASA projects while they're here at school. And microgravity is definitely one of those.
May I ask a question?
Sure.
Do you have to be a STEM student to be a Space Bronco?
Absolutely not. Space Broncos is really driven to be able to show that we're an interdisciplinary team. You don't have to be an engineer or a scientist to be interested in space. NASA itself has many different people working there, historians, accountants, all different kinds of people that work in different fields.
TV production people.
Yeah, exactly.
Absolutely.
So Space Bronco is kind of open to all the students at Boise State.
Absolutely.
Okay.
Yeah.
Okay,
We welcome everyone.
Okay, great.
And we are looking for more. Right?
Yes, we are. We are looking for more now. That would be awesome.
That's really good news. I hope the students who are watching this program and like to involve with space and science and engineering reach out to you and get involved.
The other thing that you really get out of it by being on the Space Broncos team is a lot of leadership skills, communication skills, and teamwork skills. So they're just great lifelong skills that work for your future career or anything that you're doing.
Okay, since we are talking about the Space Broncos, let me ask you this. So if students get involved in Space Bronco, is it like a credit? Or is it like an extra activity? Is it like a...
It depends on how the program is set up. I know for the past Space Bronco events, I did get a credit for the activity that we did and for the project. So it kind of depends on the project and how it's set up for that semester.
And so that first year, last year, when Camille and all the other Space Broncos worked really hard to set up that wonderful downlink that we had with our professor of the Boise State University professor of the practice, Steve Swanson, who was commanding the International Space Station. So Steve, by the way, is a mission specialist astronaut also, just to make that distinction, which really doesn't matter. But I bring it up anyway. But so in all of that planning, that first year, we actually did set it up as a class so the students could get class credit. But in talking with the students, and it's student-driven, which is what we love best. They're the ones who make the decisions. They have the great ideas. And so the students felt it would be a great thing to have it be a student club. So that's the way it's going now, and it's going to continue to grow, and it's wonderful.
Great. So Camille, you introduced President Obama before his remarks at Boise State in January 2015.
That's something we do not have in common.
And President Obama mentioned your name, and we have a clip here, and you can see it on the monitor right there.
Hello, Boise State! Oh, it's good to be back. Can everybody please give Camille a big round of applause for that introduction? I love young people who are doing science, and I especially love seeing young women in sciences, and so we're very proud of what Camille's doing. You know, you heard Camille's story. She's a mechanical engineering major. She's a great example of why we're encouraging more women and more minorities to study in high-paying fields that traditionally they haven't always participated in math and science and engineering and technology. Well, Camille's done research for NASA. She's gotten real job experience with industry partners. She's the leader of your microgravity team. And by the way, she's a sophomore. So by the time she's done, she might have invented time travel by the time she's done here at Boise. But the point is, I want every American to have the kinds of chances that Camille has, because when we've got everybody on the field, that's when you win games.
Okay, that was President Obama talking about Camille. So my question is, where were you when you basically informed that you are going to introduce President Obama?
Sure.
Did they call you? Did they send you an email? Where were you?
So I was at school early that day. I think I was there for an early physics class or something. And all of a sudden my phone started ringing in a ringtone that I've never heard before. And I looked at it and it said unknown. And it was the White House calling. And they were asking me if I would like to introduce the president. And I said yes.
So it was the White House who chose you to introduce President Obama, not BSU.
Well, the Dean of the College of Engineering, Amy Mall, she nominated me.
Okay.
And she asked me earlier in that weekend, Sunday or something like that, if I would like to. And then, of course, they had to run it by the White House and everybody. And so I found out just a couple days beforehand, early in the morning, that I was chosen.
Okay, that's really
Nice to get a
exciting.
call from the White House on your cell phone.
Yeah, and it was really awesome to be nominated by faculty. That was such an honor.
Such an honor, yes, sure. And did you had a chance to talk to President Obama in private?
So before we went on stage, behind the curtain, while we were waiting to go on, he came up to me and he shook my hand and said he was really proud of me and proud of the things I was doing, and it was really nice to him. He was really so nice and really great smile, and
I'm sure he was.
Yeah, and so I felt really appreciated in that moment, I guess.
Okay, great, great. So before going to the next question, I'm talking about microgravity.
Yeah.
I interviewed Camille about a week ago, and we have a clip of that interview.
Hi, my name is Camille Eddy. I'm a sophomore in mechanical engineering, and we're here in the CMEMS lab, which stands for Ceramic Microelectrical Mechanical Systems Lab. And in this lab, we prototype and make different products of scientific interest, and we have a lot of fun doing it. The way we do this is taking small layers of LTCC, which stands for low temperature coach-fired ceramic, and we take those layers and we drill holes into them. After we drill holes into them, we would stack them on top of each other and we create a product. And we have a lot of fun. We work with faculty and professors on these projects, making sure that we're on the right track, but then they also give us the more technical and scientific feedback that we need and the principles behind what we do. So in my hand right here, I have a layer of LTCC. What we would do is manipulate this layer, maybe put it on the laser here and laser out a pattern. And then we would do that multiple times on different layers of LTCC and stack those together. So here is our lamination press. Once we have lasered out those very many layers of LTCC, we fit them together basically like a pattern. And then we would put them on these silver bricks right here. And then we wait for a few minutes, and that heat and the pressure together basically gives us one layer or one product instead of maybe the multiple layers. So this is the mill, and right here what we use this for is to drill holes or lines into our products. And it takes some knowledge of machinery, programming, like on that computer interface, and it's a great deal of work, but you know, we get very clean holes out of it and very clean lines. So after we've lasered the LTCC, we've milled the LTCC, we've gotten everything we want in there, we would then bring it over to the furnace and fire it. And what that does is it takes it from that green state that was pretty malleable. You can move it and bend it, and it actually can tear. But we put that into the furnace, and once it goes through its process, it comes out hard. So here at this table, we have some other pieces of LTCC that have been worked on. There are different pieces. You can see the different features that have been either milled or laminated in. Here at Boise State, there are many research opportunities that undergraduates can get involved with, where it gives you the chance to work with faculty and mentors as well, and to get real engineering experience in the field. You can contact maybe faculty you know, or contact someone in the advising office to get these opportunities. It looks great for your resume, graduate school, future jobs, and it gives you a really great experience working with people, working on a team, and then getting some sophisticated engineering research in.
So this video will be available on UTP YouTube channel. And so Camille, tell us about microgravity neutral buoyancy experiment design team, or micro-G-NEXT. Hope I pronounced it right. First, how do you pronounce the acronym?
Micro-G-NEXT.
Okay,
yep, you got it.
Tell me about it.
Sure. Micro-G-NEXT is an exciting program, a part of Microgravity University. Some people might have known about the flight program, where they went in the plane that had the parabolic flight, and they experienced about 30 seconds of weightlessness in that program. So this is a new program called Micro-G-NEXT. And so we're still studying microgravity, and we are going to be studying this in a neutral buoyancy lab, which is basically a really, really big pool down at NASA Johnson Space Center, where they simulate the effects of microgravity in that pool. And they can do all kinds of different science experiments down there. Our project for Micro-G-NEXT is to create a surface float sampler where we pick up loose rocks from a simulated asteroid surface. So we want to be able to pick these up so that we can sample them, and then be able to take 3 samples at a time that can't get cross-contaminated. So our job is to build a tool that can do this for the astronauts when they go on an asteroid mission.
Okay, great. Barbara, are you involved in this program, or and does this program have any affiliation with NASA?
I am involved, and I'm delighted to be involved. We have a fantastic team. This year we've got 9 undergraduate students representing engineering, education, and geosciences, and they're working together beautifully to design this tool. So you asked if this is affiliated with NASA. Absolutely. In fact, the work that this team is doing is directly, NASA asked for the work.
Okay.
So one of the future missions that NASA's working on now is to capture an asteroid using a non-human spacecraft, capture it, move it out of its trajectory and put it into an orbit around the moon, and then send up a team of astronauts on that new space vehicle that I kind of mentioned earlier called, well, doesn't matter what the name is, it's Orion, but that would take the crew, meet up with that asteroid, and then do some geology with that asteroid, so do some scientific studies. And so there are several different things that they want to do, but one of the things they want to do is to be able to take samples of different pieces of that asteroid and then return them to Earth for study without cross-contaminating. So if you take a sample here and then you move over here, how do you do that without getting any contamination from here when you move here? Because asteroids have a very, very low gravity field. So you just touch, and you're going to have dust and rocks flying everywhere. So it's really a technical challenge. And NASA's working on the spacesuits for this now. So how do you take the current spacesuit that we have and make it more workable for astronauts working on an asteroid? And they also need to work on the tools. So just, the tools that we currently have aren't necessarily the right tools for the job. So they put out this challenge to university students, help us with these tools. So this is real work these students are doing.
Okay, great. So do you have anything to add on that?
Oh, well, yeah. I always call it a NASA undergraduate research experience. So, it's definitely a research experience where even though we're building, it's not necessarily what you saw in the lab that I was doing earlier, but it is a real research experience because we have to figure out how to make this tool best work to the specifications that NASA set forward for us.
Okay, so is Boise State unique in having this kind of program? Are we the only university?
No, we're not. Other universities have it, and we're in really, really great company. So this is actually a competitive program, and the different universities have teams that apply to the program. In some universities, the teams are students that just kind of come together and get some faculty to help them, because you need faculty advisors. In other schools like Purdue and Boise State, it's actually built into our program here at Boise State University. So we have our Boise State University Microgravity University. And this is one of the examples. Camille mentioned our flight program the last several years where the students would design and propose an experiment to fly on the microgravity aircraft. And we've been involved in several. We had a team several years ago who worked on a design for the NASA Pisces program. And they were looking at how do you store seed products, so for food products on the surface of the moon or on Mars. This is way into the future, but that was another real project that our students worked on.
Right, so I have more questions, but unfortunately we're running out of time. In the remaining time, I would like to ask you, what is your plan to help students like Camille to get involved and basically produce more Camille?
Well, Camille actually is such a role model, as she and the other team members, and also through the past. So several of our past team members are still on campus. Some end up working as graduate students helping out our undergraduate teams. But I think, and I'm glad you asked that, because I think a lot of it has to do with our K-12 part of this. And so Camille and the team are involved in all kinds, and other people on campus too, in all kinds of outreach where we can give our K-12 students out in our community the same kinds of experiences and allow them to come on campus. And Camille's a great example of that through our IDO Science and Aerospace Scholars program, through microgravity outreach. We have another program called Zero Robotics, so and many, many other outreach programs, not just microgravity and not just NASA, but across the campus.
Okay, very briefly, Camille, what is your plan after you graduate? I know you're a sophomore, you have 2 more years, so have you ever thought about your next plan?
Oh yeah, definitely. After I finish here at Boise State, I would like to go on to graduate school.
Great.
Maybe study systems engineering or aerospace engineering for a graduate degree.
Great, well, good luck. Thank you, Barbara Morgan and Camille Eddy. Thanks for your time. And unfortunately, we are out of time. I want to thank Barbara Morgan and Camille Eddy for joining us. I am Farzan Faramarzi, and until next time, have a wonderful day.